So hi again. We're going to talk about electromagnetic waves next. And I've got a few links here that I'm just going to show you really quickly. But essentially, electromagnetic waves are just that. They're electric field and magnetic field waves propagating or traveling through space or through some medium, whichever it might be. So here's an example of electromagnetic wave. So if you follow the first link, you'll find this one. I can play this video. There we go. Now it turns out, so if the blue is the electric field here, you have a electric field produces a magnetic field, and we know that because we can see that with the magnetic field around a wire with electricity running through it. And then the H here, which is it's a symbol for magnetic field, that's oscillating in perpendicular motion. And it turns out the electric field creates that, but also the magnetic field, if it's changing, it produces an electric field, which then again produces a magnetic field, and so on and so on. And so it essentially it's self-perpetuating and it travels through space at the speed of light, it turns out. Let's see if I can show you one of these other applets. Go to this one. This is another one, essentially the same thing. Just different graphical representation of the same thing. Here you can see it traveling out in two directions. This one particular line. So let's stop that. And that's all. You can look at this other one. There's another applet right here. There's the next slide. Just a quick story about electromagnetic waves. There was a fellow back in the 1800s who lived and worked around in the late 1820s and up to the 1850s. He had tremendous longevity. His name was Michael Faraday, and he discovered that an important relationship between magnetism and electricity. But he was an experimentalist, and he wasn't schooled in a classical sense. He managed to get into his experimentalism because he was in favor of a famous scientist. So he wasn't from the upper class, but he did pioneering work, and he was one of Einstein's heroes, actually. So he couldn't really do the math. So he asked another fellow. Faraday was British and English, and he asked a brilliant Scottish mathematician by the name of Maxwell if he could help him out with the math. And Maxwell did. And so Maxwell made some famous equations, and he noticed in there that there were some values using some universal constants that if he plugged in the numbers, it came out extremely close, essentially equal to that of the speed of light. And so he theorized that light itself was electromagnetic in nature, and this gave rise to hypothesized things like, light is essentially the same thing as radio, and so radio was essentially born right then. And it wasn't too many years after that you had things like the radio sets broadcasting Morse code, and somebody shortly after that they figured out how to send like voice, and then TV. So here's the full spectrum of electromagnetic energy. It ranges all the way from down here, these very long wavelengths, in low frequencies that we use to broadcast radio and TV. And as you get higher in frequency, shorter in wavelength, we call those, there's a certain band there we call microwaves, and radar uses microwaves, and that was invented somewhere around late 1930s, 1940s, and it was instrumental in helping England survive in the Second World War. They had these radar stations posed on the southern shore, over by the English Channel, and they could always pick up and tell when the German aircraft were coming over to bomb them, and so they'd scramble up their fighters and live to fight another day. And Germany couldn't figure out how these British were always getting so darn lucky. Always managed to fighters managed to be wherever they sent their bombers. And so that was I mean, it's the same sort of thing that you find radar stations at airports and such, radar detectors detect that, so police can use radar-based speed detectors to see how fast you're going. And then you can heat your sandwich with that too. Microwave ovens operate by emitting microwave energy. And now if you keep going up in energy, you eventually get to heat or infrared. So if you look at things like your remote control for your TV, if you look at the little lamp, I'll call it, on the end of it, you can't see anything coming out of it, but the TV can see something. In fact, if you hold that up to your digital camera, or you make a short recording of that, you'll see that indeed the camera can see in infrared, but you can't. As the next area of the electromagnetic spectrum is the visible spectrum. This is what we can see. Our human eyes are sensitive to electromagnetic energy radiation of this particular wavelength and frequency. And it's a very small band, probably smaller than what's really shown here, from all the way from red. This is Roy G. Biv, our red, green, red, orange, yellow, etc., up to violet. And as you keep going up in energy past that, or higher in frequency, you get into the ultraviolet range, which causes your sunburns. And keep going up in energy, up in frequency, shorter wavelength. And you get into X-rays, which can penetrate through skin, but not through denser tissue like bone. And so the bone creates a shadow, but the skin doesn't. That's how you can see pictures of your bones in X-rays. And beyond that, we have gamma rays, which are extremely high intensity, high energy electromagnetic waves which come from things such as nuclear reactions and such. And this is just another graphic showing the full electromagnetic spectrum. And yet another one. And that's it. That's what we're going to say about electromagnetic spectrum and electromagnetic radiation. Key here is also understand that maybe some all of these waves, whether they be gamma all the way to radio, they all travel at the same speed. So if you look at the relationship, say, between the wavelength and frequency here, there's a general relationship that it's off by about the product of these two should give you about the speed of light, 3 times 10 to the 8th, and you can see they're off. If you multiply them, they give you about 10 to the 8th there. So that's it. Okay, see you later.